For example 2, we're given the reaction elementary steps, but we need to determine the overall reaction and number of colliding particles. So we need to look at the reactant side. For step number 1, we're colliding two compounds, hydrogen bromide and oxygen. So there are two particles colliding together. Same with for step 2, step 3, 1, 2, and then step 4. They give us the relative speeds of each elementary step. And because step number 1 is the slowest, that will be our rate determining step. Based on this given information, we need to cross out all of our redundant or our intermediate compounds, and we will get our overall reaction. So we're going to cross out everything that appears on both sides of our of each reaction of HOBr and two equivalents of them, but we have two on the left-hand side as well. We can now write down our final reaction where we have 1, 2, 3, 4 HBRs as our reactant plus oxygen O2. And that's going to form into 2 H2O, as well as our bromines. We have 2 of them. The rate determining step, as mentioned before, will be the slowest step, which happens to be step number 1. That step will help us determine the rate law equation. So the rate determining step is step number 1, and that equation is HBr plus oxygen forms into HOOBr. So it takes a while for this reaction to occur, meaning it takes some time, the slowest amount of time, to form this intermediate. So the rate law is dependent on this reaction alone. The rate is dependent on the reactants here. So the rate is equal to rate constant K multiplied by hydrogen bromide multiplied by the concentration of oxygen. For this reaction, it's all 1 to 1 to 1. So the exponents here are understood as 1. So each exponent is 1 as well. The reaction intermediates are the species that you crossed out. So we crossed out HOOBr as well as HOBr. For example 3, we're going to look at just a two-step reaction. Our overall reaction will therefore be the compounds that persist and do not get crossed out. So our overall reaction will be 2D plus E plus F as our reactants, forming into DF and compound DE for our product side. The rate determining step is always going to be the slowest step. So that is going to be step number 1 in this case. So step number 1, where we have 2D plus E to form D2E. Therefore, the rate law equation will be based off of this equation here, where we have the reactants of D, and therefore the concentration of D and the concentration of E, where the exponent for D will be square, or 2, and E will be to the exponent to the power of 1. The reaction intermediate is just D2E.